Okay, so compound inequalities. All right. So a compound fracture means that we're breaking the bone in more than one spot. Specifically, we are looking at two inequalities. So instead of writing them out as two separate statements, as you see in problem number one, we could actually just kind of write it out as one, but really it's two inequalities. Now, if you look down a little bit lower and we look at something like question number two, yeah, you can clearly see the two inequalities. Problem three, yep, problem four, problem five. Okay, now, yeah. So a lot of times your compound inequalities will be written with just one statement. Now, the other thing we have is we have an and statement or I don't want to say or, all right, or an or statement. In an and statement, it's kind of as it sounds. You need both things. All right. Well, listen, I'll go tonight, but I'm going to need $25 and I want to be able to stay out to 10 o'clock. All right. So you want both of them. Whereas an or, it's just kind of like choose. You listen, you can either eat your vegetables or you can clean your room, whichever one that you want. So we're going to skip around a little bit. I'm going to go down to problem number two. All right, and let's walk you through this here. So, hey, business as usual. There are just two of them. We're just going to solve. So for the first one here, hey, let's divide both sides by 4. So I've got x is greater than -3. Oop, greater than or equal to -3. Okay, all right. On the other one here, yep, let's subtract 3 from both sides. So x is less than -10. All right, it is an or statement there. So now we're going to graph it. And you're going to want to graph first before you get into your, wait, what's it called again? What's it called? Where you write it out differently when you're talking about your possible solutions that are there. All right. What is it? Oh, it's up there top. Yes, interval notation. All right, seriously, I forgot the word that's there. So yes, interval notation. So I'm going to put down -3. That's one of my markers. Okay. And then, oops, -10. So, all right, wait a second. We need things in order from least to greatest. So that's not a good spot for -3. That's a good spot for -10. And then, yep, we've got -3. Now, I do see the or equal to symbol over here. So when I look at that's with the -3, I'm going to come over here and I know it's a solid circle on it. I can see I have just a less than symbol with my -10. So that means I'm going to use an open circle that's here. All right. Now it's an or statement. So it could be either one that's going to work. Now, the nice thing about or statements is we can just start graphing it right away. So x is greater than or equal to -3. Well, that would be this way, all right? And then numbers that are less than 10, -10, excuse me, that would be this way, all right? So because of this, when I write out my interval notation, I'm going to start with the smallest number. So that's going to go from -infinity, gets the parentheses, and I'm going to go up to 10, and it's an open circle, so you're going to get parentheses. Now, if I kind of go up to the top of the page here, all right, it's with an or statement. With an or statement, we're going to use your union symbol, all right? So let's come on back down there, all right, and we're going to put in our union symbol. Okay, so mathematically it means, hey, it can be from -infinity to 10, or, and now we're going to go ahead, -3. Hello. Yeah, no. What are we going to? Yep, we're going to change it to a bracket here. Yes, because of that shaded in circle, and we're going out to infinity. I can't land on it. All right. So that's your whole answer. So again, we've got our inequalities, we've got our graph, and then you can see we also have our interval notation that's there. Whew. Let's go to problem number 3 because it separates them, but it's also an and statement this time. So we'll go ahead. Hey, let's add the 6. No big deal. X is less than 11. All right. And let's add the 4. Add the 4. Okay, so x is greater than 6. All right, so get my 6 down there, get my 11 down there, because those are my key terms that we're using here. They're both greater, I got a greater than, a less than symbol, so they're open circles that are on there. Now again, it's an and. So I need both of them to be true. Now check this out. Because it's an and statement, all right, numbers that are greater than 6, I'm actually going to go above, all right, the graph. I'm not going to graph on it like I did in the other one here because I'm not ready for the answer yet. So numbers that are greater than 6 is going to go this way. Numbers that are less than 11 is going to go this way. So because it's and, I need them both to be true. The overlap is where they're both true. Where do they overlap? Right in between there. All right. So only the numbers in between there will be true. And we can test this out. So numbers between 6 and 11. There's a lot of numbers that are in between there. I'm going to stay with whole numbers. And I'm going to choose the number 8. All right. So I can plug it in. Is 8 minus 6, that's 2. Is 2 less than 5? Yes, it is. Go over the other side, plug in the 8 again. 8 minus 4, well, that's 2. Is 2, I'm sorry, no. 8 minus 4 is 4. Ooh, is 4 greater than 2? Yes, it is. So it worked for both of them. If I choose a number to the right of the 11, so like 20, what I'm going to find is I'm not going to get a true statement. 20 minus 6, 14. Is 14 less than 5? No. All right. Now, if I put it over here, 20 minus 4, that's 16. 16 greater than 2. Yes, it is. But it's not an or statement. It's an and statement. So they both need to work. All right. Let's find someone else to play with here. Ooh, let's go up to question number 1. Now, question number 1. I don't see an and or. Let's see, here we go again. Or and or. All right. Oh, go ahead. Or. Go ahead. Make your best seal impersonation there. It wasn't my best, but I did make an impersonation there. So the idea is because it's technically 2 of them, you actually just do it to both sides. So opposite of subtracting 9 is to add 9. So I'm going to add it to the 10. But we're also going to add it to the negative 5. Because again, both sides, I've got 2 inequality symbols. Now, I could come off to the side and rewrite it as 2 of them. Negative 5 less than x minus 9. And then write it out the other one, x minus 9 less than 10. And then solve it. But this just kind of speeds up the process here. So goodbye. I just have the x. All right. I've got a negative 5 plus 9. That's a 4. Bring down my less than symbol, and that's a 19 we're looking at. Okay, so 4 and 19 are my key numbers that I am after here. And so when I'm looking at this, all right, wait a second. The x with the 4, so open circles because they're just less than symbols. Now, I have to be careful here because technically this doesn't, you might want to kind of read it. This is really x is greater than 4. Either you can read it backwards, or remember, if you flip the sides, you have to flip the inequalities. And then I can see you here, x is less than 19. All right. So greater than 4 is going this way. All right. Going this way is our less than or 19. Now, here's the thing. I don't know if it's an and statement or an or statement. So what you can do here is just test it out. Now, I'm going to show you this testing out because we're going to use this later on. There's other techniques here, but I'm just going to stick with this for right now. We're just going to test things out like we did in the other problem. So someone bigger than 19, I don't know, 20 that's there, all right? We're going to see if it's true. So 20 minus 9 is 11. We're just plugging it in. And we want to see if this is a true statement. Is 11 less than 10? No. So I'm not going to shade over here. Let's go between the 4 and the 19. You can choose anyone. I'm going to try 10. 10's a friendly number. So 10 minus the 9, again, we're just plugging it back in. 10 minus the 9 is a 1. Okay. So in this case, all right, is 1 less than 10? Yeah. But I also got to check the other part of it. Is 1 greater than negative 5? Yes, it is. So here we go. So that means, yes, it's winning. That is accurate. So those are where my correct answer is at. So we are in between anything between 4 and 19. Now, I can't choose like 4. Oh, wait. I can't choose 4 because it's got to be greater than 4. That's that open circle on it. And if I wanted to test it out, I could choose someone to the left of 4, like 0. 0 minus 9 is a negative 9. All right. Is negative 9 greater than negative 5? No, it's not. So again, I can see that's what's winning in between here. So if we don't get a clear and statement or an or statement, then testing out and seeing if it works is definitely something that we can make use out of. Now, we are going to look a little bit more tomorrow into this whole less than. There's a thing out there where it's less than symbols, less than and symbols, greater, or symbols there. So we are going to kind of get into that particular conversation that's there. But certainly testing it out because it's all one. Yeah, we can go ahead and test that out. Let's try one more person. Let's try, no, not you, not you, not you, no, no. You know what? No, let's just go down to problem number 5. Let's just do 5 here. All right. So, okay, I'm going to add 1 to both sides. All right. And I mean both sides literally because the left side and the right side. So I've got 3 is greater than or equal to x, which is greater than or equal to negative 2. Okay, so negative 2 is one of my numbers, and then 3 is my other number that's there. Okay, so let's see here. Let's plug in someone that's way over here, like a 10. All right, is 3 greater than or equal to 10? No. I know where it's going to be, but just for fun. Let's go to the other side of the negative 2. So like negative 10. So if I plug it in, is 3 greater than or equal to negative 10? Yes, it is. Now, hey, is negative 10 greater than or equal to negative 2? No, it's smaller. So it's not working over here, which means it has to be what's in the middle. So I'm going to shade it because, again, the or equal to with the negative 2. I'm going to shade it because of the or equal to that's associated with the 3. And it should be what's winning in the middle. Now, let's just check, let's just check 0 because 0 is between negative 2 and 3. So here we go. Is 3 greater than or equal to 0? Yes. Is 0 less than or equal to, oh, I'm sorry, 0. Oh, I got distracted there with that warning sign that's there. I got the wrong one that's there. Is 0 greater than or equal to negative 2? Yes, 0 is greater than or equal to negative 2. So that means, yes, we're going to shade in between there. Woo! That's a lot here, people. All right. Now, the one thing is interval notation, which I think I forgot on the previous one. So let's check it out. I'm going as small as negative 2. I'm going as big as 3, and I can be brackets. No union symbol because it has to be between there. So if I go up to that other one that's there, yes, same thing. I'm going from 4 to 19. I can't land on it, so we have just our parentheses that are there. Whoo! Here we go, people. It's on. We'll see you later.